What's up, y'all? Bro, y'all remember back in 2K23 you had the 6'8" LaMelo Ball demigod builds with a 90 dunk, a 99 acceleration, 99 speed? Yo, have you ever wondered what's the difference? What's the difference between speed and acceleration? Well, put it like this. Let's say you have De'Aaron Fox, right? And let's say you have Yao Ming, or not Yao Ming. Let's say you have like a really big center.
Long
But
rebound, Nick Young.
if you ask how fast they can run, they might both say, I don't know, 10 miles per hour or whatever bullshit, like 15 miles per hour, whatever. Just say 15 miles per hour, okay? But if you ask them to run a sprint, run a suicide, somehow De'Aaron Fox over here. Oh, De'Aaron Fox is gone. Okay, there you go. De'Aaron Fox over here would go to the top. Okay, not the top. When they're running suicides, De'Aaron Fox somehow gets to the other side of the court faster than Mr. Center over here. But then you ask yourself, why? They both run the same speed. Why did De'Aaron Fox get to the other side of the court faster than the center? Honestly. And actually, now that I think about it, De'Aaron Fox might even sell that. Like, you know, the rabbit, the hare, and the turtle story? Nah, I kind of think of that when I think of De'Aaron Fox now, because, like, that finals of bullshit that just happened, not just happened, that was like a month ago, dude. But still, the finals, not. Forget it, bro. I'm getting off topic. But still, why does De'Aaron Fox get to the other side of the court faster than the center? It's cause a thing called acceleration. Now think of it like this. We have function p of t. Position with respect to time. Alright? So this is our position function, that's our y-axis, and their x-axis is time. So as time goes on, this is a certain player's distance from where he started from. And, you know, as time goes on, he goes to the other side of the court and runs all the way back. Right? But have you wondered how do you find the speed out of this? So just think about it. If we take the average rate of change from 2 points, can we not find how much did he change? So isn't that the speed? So essentially, calculating speed is just calculating the rate of change. And y'all did that in Algebra 1, probably 8th grade too. I did that shit in 8th grade. So you got delta y, delta x. Delta y and delta x, right? Between these 2 points. So we got, let's say that's 0.5, like t is equal to 5 and t is equal to 2. So it'll be p of 5 minus p of 2 over 5 minus 2, which is 3. Why am I doing that? Hold on. Now it doesn't erase. It used to erase when I wrote a box in it. Whatever. That's 3. So over the interval of 3, we take p of 5, subtract that by p of 2, and that's our rate of change. Now, let's say we're trying to find the rate of change at one specific point. Let's say we're trying to find oh shoot. We're trying to find the rate of change at one specific point. Let's say we're trying to find the rate of change at 4. How do you do that? Well, obviously the 2, 5 thing won't work because like that's the rate of change between 2 and 5. But what if we do this? 4 and 4.1. Wouldn't that give us a better estimate on the rate of change of 4? No, scratch that. How about we do this? We do 4 and 4.001. That's closer to 4. Oh no, scratch that. How about we do 4.0000 repeated 1? That's infinitely more closer to 4 than 4.1. But then, do we know what's 4? Do we know what's 4.000 infinity? Like the 0 goes on to infinity, then 1 minus 4? Nah, we don't, because we don't know how to measure infinity. So what can we do is this. this little trick over. What the hell, dude? Yeah, this little thing over here. The limit definition of a derivative. It might seem scary at first, but trust me, it gets better. So the limit as h goes to 0, f of x plus h minus f of x over h. You saw it here. So f of x plus h, so our interval from 2 to 5 was 3. So 2 plus 3 minus f of x, so p of 2 over h, our interval is 3. So that's basically just as the interval gets closer to 0, the second point minus the first point is the average rate of change at this point, and that's speed. Because remember, speed is distance over time. That's basically rate of change. That's delta y over delta x. Now, why does this all matter? Low key, now I'm telling you this. How the hell would you use this in math? Like, dude, this is way too much work. This is way too much to take in. Honestly, I thought that at first too, but if you think about it, every time you put a function in this and try to solve for h, it's gonna take you hella time to do it. But there's some really smart asses out there, like complete Einsteins, that did this for us and made a little rule. And that, whoa. Alright, and that's called power rule. Okay, so let's say you have p of t, and that's equal to, let's say we made a function out of DEARON Fox's speed while running the suicides into x squared bullshit. So x squared minus 5x plus 3, right? So the power rule states that whenever we have a function, what can we do is we can multiply the exponent to the front. So let's say we have x to the power 3, we can multiply 3 to the front, and then you have to subtract 1 from the exponent. So at the end, that becomes from x to the power 3 to 3x squared, right? That's super simple. Just do that. So let's say you have x to the power 5. What would that be? That would be 5x to the power 4. Let's say you have 3x to the power 5. What would that be? Remember, you just multiply the 5 and subtract 1 from the exponent. So that would be 5 times 3 is 15, and 15x to the power 4. Alright, so let's do that here. So if we're trying to find the derivative of p of t, we're trying to find the speed of p of t, the function of speed for p of t, honestly, because we haven't plugged in a point for t yet. Well, I fucked up really bad, yo. Okay, hold on. These are all t's, these are not x's. I didn't do any of that. It's actually t squared minus 5t plus 3. Whoops. Alright, so we're trying to find p prime of t. My god, bro. Alright. So if p prime of t would be equal to 2t, because remember, 2 goes out here, 2 minus 1 is 1, so 2t minus 5, because look, t has a power of 1. 1 times 5 is still 5, and t to the power of 0, because 1 minus 1 is 0, is just 1. So just 5 plus 0? Why did this become 0? Well, think about it. There's nothing here, so this is already like gone, basically. There's no... Shoot, hold on. There's no exponent there, so there's basically a 0. It's 3 to the power 0, and that just becomes 0. Like, there's... How should I explain this? It just goes away because there's literally no variable here, so that just becomes 0. So the function of speed, or velocity now you can say, that's a little math for me keep in the back of your head, would be equal to 2t minus 5. So let's say we're trying to find the velocity, or okay, rule of thumb, speed is the absolute value of velocity. Okay, just remember that. So we're trying to find the speed at t is equal to 4. So v of 4 would be equal to 2 times 4 minus 5, which is basically just 8 minus 5, which is 3. And there you go. 3 miles per hour, meters per second, whatever De'Aaron Fox runs. But see how that worked? Now, okay, we found the speed, but what about acceleration? Because remember the original problem. Why did Mr. Yao Ming over here ran the same speed as De'Aaron Fox, but reached there lower? Because his acceleration was low. Now, acceleration is the speed of the speed. If you know what that means, it's basically how fast can you go to a certain speed. So remember, the derivative of velocity is equal to acceleration. So a of t is equal to v prime of t, which is equal to p prime prime of t, if that makes sense. So remember our original function over here, our second function over here, v of t is equal to 2t minus 5. And remember, if you just use power rule, all we can do is just 2, because the 1, 0, whatever, from 0, t goes away, 2 times 1 is 2, minus 5. The 5 becomes 0. So our acceleration is basically just equal to 2 miles per hour, because remember, over interval is distance over time. So distance over time, first off, that's our speed, and then put that over time again is our acceleration. So it's 2 miles per hour, if that makes sense. I'm not a good teacher, I'm sorry. My math teacher can do way better than me. But honestly, just remember this power rule and try to find derivative. That's like a simple way you can put derivatives. Honestly, it's I'm just bad explaining at things. I'm just bad at explaining things. Shoot, I can't speak, bro. I'm just kind of bad at explaining things. Well, just use this power rule. Honestly, that's the best thing you can take away. There's a bunch of other rules like product and chain and like other stuff like logs, natural logs. Well, I'll cover these later. Honestly, I might cover them like tomorrow if I got time to make videos. I haven't been posting videos lately because like I'm kind of lazy. And on the talk of 2K, fuck Ronnie, fuck Mike Wang. And just shout out to Henry Visar, Zuby, and Kingston Flemings. I know y'all new Atlanta Hawks. I know y'all will do great things. And this whole explanation was out kind of all over the place, but I hope this kind of helped. Just remember, use this power rule to find the speed and acceleration. Speed is basically how fast you go, and acceleration how fast you get to that speed. That's basically it, honestly. So I hope y'all enjoy this video. Just let me know if you want to know something else, or I could have done something a lot better. See y'all later. Go Hawks.